Hello everyone. In the previous class, we see about the properties of a definite integral and we complete the three properties of definite integral. Third one is this that is integration from a to b f of x dx equals to integration from a to b f of t dt. Right? That is what is the meaning of this? If we change the variable, then integral is not affected. Right? Then this the next property is property number 4, that is integration from 0 to a f of x dx equals to integration from 0 to a f of a minus x dx. That is variable is replaced by upper limit minus variable. What is meaning of this? See here, variable is x and x is replaced by upper limit a minus variable x. That means variable is replaced by upper limit minus variable. This is the actually meaning of this property. Now this is the actually very important property, and try to understand, because this is important in the sense of problems also, because in a lot more examples we have to use this property, right? So see how we prove. First of all, again let integration f of x equals to g of x plus c, that is we considered. Then again consider RHS of the proof, that is integration from 0 to a f of a minus x dx. This is the right hand side of the proof. Okay, then put a minus x equals to t. This a minus x equals to t we have to put here, and therefore from this x equals to a minus t, and the minus dx is dt. Dx equals to minus dt, right? Because derivative of x is dx and t is dt. Minus is negative sign, is because a is a constant and derivative of a is 0, right? So 0 minus dx means minus dx. Okay, and if we substitute, then the variable limit also changes. As x tends to 0, that is x from 0 to a, then t varies from a to 0. How we find is, see put here, if x equals to 0, in a, if we put in substitution, then a equals to t equals to a we get, right? And if we put x equals to a, then we get t equals to 0, right? That means limit changes from a to 0. So therefore I becomes a to 0 f of t of minus dt, right? That negative sign constant take outside the integration, so minus of a to 0 f of t dt. Okay, then according to the property, previous property number third, if we replace the interchange the limit, then symbol changes, right? So this is converted to 0 to a f of t dt. Negative sign is cancelled, right? According to this property. Okay, so again by the same property number third, this is actually according to property number second, and this is property number third, that variable changes do not affect the integral. So 0 to a f of x dx, t converted to x, as different integral is independent of the variable, right? And this is nothing but the left side of the proof. Okay, so this is the proof of the property number third or property number fourth. And what is meaning of this? That variable is replaced by upper limit minus variable. Here x is variable and x is replaced by upper limit a minus x, so there is no change in the integral while doing like this. Okay, then see the next property, that is property number 7, sorry, property number 4. After this is property number 5, that is integration from a to b f of x dx equals to integration of a to b f of a plus b minus x dx. What is this? Variable is replaced by sum of the upper and lower limit minus variable, where lower limit is a, upper limit b, sum is a plus b minus x is the variable, right? So again this proof of this is also same. Let 0 to here 0 to f of x dx is g of x plus c, and again consider right side of the proof, that is integration a to b f of a plus b minus x dx. Okay, and put a plus b minus x equals to t, as we put in the previous example. A minus x equals to t, that is the right side, the bracket term of the right side is substituted. Okay, So again a plus b is constant, so minus dx equals to dt, the dx equals to minus dt, and x is what, x is a plus b minus t from here. Okay, so x tends to b, t tends to a. So this is the limit change actually. X tends to a, so t tends to b. How we find? Put here x equals to a, so a minus a, we got t equals to b, means t tends to b. And if x tends to b, put here x equals to b, so b minus b is 0, and t equals to a, so t tends to a, right? So this is the changes. So now therefore limit from b to a, f of t minus dt, so it's negative sign again constant, take outside the integral, right? And by using property, this negative sign merges when we interchange the limit. Okay, then b to a converts to a to b, and then in the as same as previous, that is change the variable, right? So it is f of x dx. This is the left side of the proof, right? Which is very, this proof is very similar to the previous one. Okay, so this is the nothing but the property number of 5, which is also important one, which is asked in the exam, right? Then see the property number 6, that is integration from 0 to a f of x dx. Sorry, this is the fourth one actually. Okay, see the next property, this is actually next property is that is 0 to twice a f of x dx equals to 0 to a f of x dx plus 0 to a f of twice a minus x dx. This is the property number 7. Actually numbering is a mistake in the textbook, so try to understand. And it is the next property, because this is number 6 actually, but this property is completed, right? And this is the property number 7. So see here, again consider the right side of the proof, right? There are two terms, so I1 plus I2 we considered. I2 is f of 0 to a f of twice a minus x, and this is I1, right? So here also put twice a minus x equals to t, as we prove in the previous as we put in the previous proof property also. So from here x equals to twice a minus t, and minus dx is dt, so dx equals to minus dt, right? Property, sorry. So again limit changes as x varies from 0 to twice a, t varies from twice a to 0, right? So limit twice a to a. Okay, sorry, it is again mistake, textbook mistake. See here, as 0 as x varies from 0 to twice a, right? So put here x equals to twice a to 0. X means t varies from twice a to 0, right? So how limit changes here? Actually here also print mistake. See here, x varies from 0 to twice a, t varies from twice a to a. We want here a in place of 0, right? So make a correction. This is actually the photocopy of the textbook, so correction here. Okay, so now I equals to integration from twice a to a f of t minus dt, right? Again negative sign take common, that is constant take outside the integration, and we get minus of twice a to a f of t dt. Again by using property, this negative sign merges by interchanging the limit. Now 0 to a to twice a, actually this one. Okay, then changes the variable by using this property. So it is again a to twice a. Here printing mistake is there, right? So therefore integration from 0 to f of x dx is integration from a to twice a f of x dx. Here also printing mistake. Okay, from equation 1 put that in the both the I1 and I2. So I1 is 0 to a f of x dx, and I2 is this, that is a to twice a f of x dx. Here also printing mistake. Here we want a, and then using property number 3rd, that it is 0 to a and it is a to twice a. The function is same, so it is 0 to twice a f of x dx by using property, right? And this is the left side of the proof, right? So here a lot more mistakes are there in the textbook, so try to understand and correct that mistakes. Okay, then we see the next property, that is the last property of the uh, definite integral, that is even function and odd function, right? That the result of that property is different for even function and odd function. So we take that property also. Before going to start that last property, we have to know the meaning of even function and meaning of odd function. So first of all, we understand that thing. So meaning of odd function, what is the meaning of odd function? If f of x is odd function, then f of minus x equals to minus f of x, right? If any function has f of minus x equals to minus f of x, then that function is odd function. On the other hand, if f of minus x equals to f of x, that function is even function, right? Means any function merges negative sign, so that should be even, and if not merge that negative sign, that is odd. So see, this is the last property, and the result of this property is different for even and odd function. That is, if integration from minus a to a f of x dx equals to 2 times integration 0 to a f of x dx if f of x is even function, and the result of this equals to 0 if f of x is odd function, right? So see, first of all we write that if function is even, f of minus x is f of x, and if function is odd, f of minus x is minus f of x. Okay, and then consider again left side of the proof, that minus a to a f of x dx, and that is equals to minus a to 0 f of x dx plus 0 to a f of x dx. Now we know that 0 is in between minus a to a. Okay, and by using property number third, that minus a to 0 and 0 to a we consider, so this is split like this. Okay, again consider one of the term, the first term from this equation number 1, that minus a to 0 f of x dx, and put here x equals to minus t, so dx equals to minus dt. Okay, then x varies from minus a to 0, t varies from a to 0. How it is? Put x equals to, see here lower limit is minus a, so if we put x equals to minus a, we got t equals to x equals to t, or t equals to x. Okay, so lower limit becomes a, right? And if we put a 0, then that is 0, so that means lower limit is a and upper limit is 0. Okay, so 0 to a f of minus t minus dt, again negative sign take outside the integration, so it is 0 to a f of minus t dt. Okay, then by using property this one, that the negative sign merges if we interchange the limit, so 0 to a f of minus t dt, and again by using property change the variable, so 0 to a f of minus x dx, right? Now equation 1 becomes that 0 to a f of minus x dx plus 0 to a f of x dx. Okay, that is integration limit is same, so we can merge the integration, so 0 to a f of minus x plus f of x dx, right? Now we know that if function is odd, f of minus x is minus f of x, hence this is minus integration minus a to f of x dx equals to 0, because minus f of x plus f of x is 0, right? And if function is even, then minus integration f of minus x equals to f of x, hence this becomes f of x plus f of x, means 2 times f of x, 2 is constant, so it is 2 into integration 0 to f of x dx, right? Hence if integration minus a to f of x dx equals to 2 times integration 0 to f of x dx if f of x is even function, and equals to 0 if f of x is odd function, right? So this is the last property of definite integral. We see the 8 properties of definite integral, which are very important. First 3 are important to prove the another 5 properties, as we see. So try to understand all the properties, because it is very important, and one of the properties asked in the examination every year, most of the times, right? So try to understand. If you face any problem, so ask me personally in the personal WhatsApp number. Right now, the next topic of this chapter is some examples are there depending on the properties, so that should be considered in the next lecture. This is enough for the today. Try to understand all the properties, and make sure that all the properties are very important. Okay.